So in today's video, we're going to be talking extensively about GraphQL schemas and GraphQL queries. And afterwards, we're going to be making a simulated GraphQL query with an Apollo client, and the request is going to be fulfilled by a GraphQL dummy server. This is an ongoing series, so if you don't know anything about GraphQL at all, I'd advise that you pause this particular video and click on the link that is showing right now at the top of your screen so you can get up to speed with the previous series, which is basically an introductory section on GraphQL. And afterwards, you find your way back here and join the moving train. Let's get into it, guys. So the first thing to understand is that GraphQL is language agnostic. This means GraphQL is independent of any programming language. It is not tied to any programming language, just like you have it in REST and SOAP, right? So having understood that, the next thing is to also understand that GraphQL as a whole is splitted into two sections. There is the client side of GraphQL and there is the server side of GraphQL. The client side of GraphQL is responsible for initiating requests. This request can either be a query or a mutation. Query and mutation are basically just fancy names, just like you have GET request and POST request in your normal REST APIs. Same way you have queries and mutations in GraphQL as well. Queries are basically requests that are targeted at fetching data, whilst mutations are basically requests that are targeted at modifying the state of the data, right? It could either be maybe you're causing an update or you're causing or you're inserting, something like that. And the other side, which is the GraphQL server, is basically the runtime of GraphQL. The GraphQL server is that component of GraphQL that actually understands the request that is being initiated by a GraphQL client. It is able to interpret the request and fulfill the request. GraphQL server side is responsible for processing the initiated requests, GraphQL requests, and executing them against connected data source. This data source can be a database, can be a legacy API or a legacy system, all right? And it's also responsible for returning results back to the client. So the next question will be, or the next, at least in my case, source of confusion will be that how does GraphQL client and server unanimously agree on what type of data can be queried or mutated, right? Like in the case of REST APIs, you would probably usually would have a request and response object, your data transfer object. So you can see what you can query and you can see the type of data that you can make a post on. For SOAP services, you would usually have a WSDL file, WSDL file, where you can see what is possible. So how does this happen in GraphQL? Well, GraphQL achieves this by what is called schemas. So let's go for a formal definition. A GraphQL schema is basically a declarative blueprint that defines the type of data that a GraphQL server can provide to our clients. It also depicts how its various clients can interact with this data via mutations and queries. So in other terms, a GraphQL schema basically serves as a contract that binds the GraphQL server and the client, where the GraphQL server says, these are the operations that is possible that I can operate on. These are the different data types that I'm able to provide. And these are the relationship between these data types. And with the understanding of this contract, which is the schema, the GraphQL client is able to accurately query the server, knowing the capabilities of the server, knowing the things that the server can process and the things that the server is not capable of processing, so it doesn't bother asking. So, having understood what a schema is, let's take a look at a real life scenario and what a schema would look like. So let's say we are asked to build a GraphQL server for a to-do application, at least way better than an Hello World. Our schema would look something like this. Now, this is what is actually called schema documents, or your SDL, schema document language. So the first thing it is that you notice on this SDL file is what is called an object type. Now the order does not matter, all right? So in this case, you would notice the object type first, but in other SDL files, you might notice other things that we're going to be talking about first. So the idea is for you to be able to recognize what each of these objects signifies, all right? So an object type is basically what you would usually call a class in other regular OOP languages like C# and Java. All right. It would usually contain different fields that can be of a scalar type or a complex type. In GraphQL, your scalar type is basically synonymous to what we would usually call primitive types in other OOP language. But in GraphQL, we have the int type, we have the float, we have Boolean, we have IDs, and we have strings. And your custom types are basically object types that are constructed for a particular purpose within the server or within the application and are embedded into a bigger parent types. So back to our SDL documents, you would easily be able to spot now that this to-do type is an object type. You might also want to see it as a data transfer object, all right? It contains other scalar types, which is the ID of the to-do, the title of the to-do, the description of the to-do, completed, and a user. Now, this user is what is called the custom type. Yeah, the ID is of ID type, the title is of string, description is of string, completed is a boolean. But this particular user property or user field is a custom type, in which if we go down in our SDL documents, you would find the definition of this same user property, this custom type. So it is basically another object type that is defined within the SDL document, and it is embedded as a custom type within to-do object, within the to-do object type. All right. So what that basically tells us is when we query a to-do, there's a relationship between the to-do and the user. We can also query the objects within users, which we're going to see when we start talking about queries. It's basically a familiar concept when it comes to creating DTOs and embedding different custom DTOs to be able to fulfill a particular shape of data that we had to return to the client. Make sense? So if we scroll down in our SDL documents, you would also find these two unique types, which is the query types and the mutation type. The query type simply defines the operation for fetching data. All right. So if you want to know what operation supports fetching of data, that information would usually be embedded within a query type object. And we also have the opposite, which is the mutation type. All right, that basically defines the operation for modifying data. So in our case, in the query type, you would see things like get single to do, that is passing the ID of the to do to return a single to do object. And we would see things like get all to dos, where you get all of the to do within the database. All right. And for mutations, you'll see things like create to do, and you'll see things like update to do. So all of this is just showing us what is actually possible in the aspect of retrieval of data, which is embedded within the query type, and in the aspect of modification and insertion of data, which is embedded within the mutation type. So this is an Apollo client. It's a GraphQL client that is freely available. And what I've done is I have connected this GraphQL client to a dummy GraphQL server. This is the GraphQL server, right? It's basically just a GraphQL server that gives you things like placeholders that has to do with to do, post, whatever. So on connecting this client to this server, one of the things it does immediately is to extract the documentation for that particular server, what we call the schema. So if you go to the schema tab, you would immediately be able to see all of the information. Now let's go to the SDL file. Now this is the SDL file, right? So what you will notice immediately in the SDL file is you can see the queries and you can see the mutations, all right? And aside from the queries and mutations, you can also see the object types. Now you can see that this is an object type and these are all scalar types, right? And you can see another custom types. Now if we go check for these photos, you will notice that this photo is also a particular object type somewhere. All right, so you see photos. This is also photo. So yeah, so you see the object called photo. All right, so that's basically how it works. Another component that I really didn't touch on is the input type. So you'd also see things like inputs. It is basically still the same concept. The concept of inputs are basically details that are used within mutation. So if you want to create a to-do, you basically are going to create an input type, right, that says create to-do input. Now this input type is what is going to be accepted by your mutations. So they are basically just the same concept. So in a schema, you would see different types. You will see types, query types. You'll get to see your mutation types. You'll get to see your object types. And also you would see inputs as well. So you take note of this input. So this input is usually used with mutations, just like I said. So this is a create to do input. This is an update to the input. So if we do a search on this, you'll find out that this is used within a mutation. So you'll notice that this is a create to do mutation, and you'll see that the input is used in there. All right. So that's how it works. What you see after this particular signature is basically the return type. So what this means is that this is going to return a type of to do. This operation returns a type of to do and the likes. So this is the schema, and obviously with the schema, it gives a lot of information to the client. So Apollo client actually makes it much more user friendly, such that you can actually check the fields. All right, you can check the fields. If we go into to do, you can see the arguments that it takes. This exclamation mark basically means it is not nullable. It has to be supplied. So you can see that it returns the fields that it returns is completed, ID, to do, and users. All right. So I know we've not spoken about queries, but with the information I have with the schemas, I can easily come to the query tab and say I want to make a query, and in my query I want some list of to-dos, and within my to-dos I want my data, and within my data I want the IDs, I want the titles, I want, no, you don't have commas, I want the completed, and I also want the users, and within my user, which is another complex type, I want the name of the user that owns this particular to do, and I also want their address, which is another complex type. I don't want another complex type. So with this, we can run our query and we should get our results in a minute. So yeah, so you can see our results. We get all of this. Now I know this is a lot of information, so I'm not going to talk about queries and mutation in this particular video. I'll just allow this particular one to sync, but in the next series, we're going to be talking strictly about queries, how to make queries, different things around queries like fragments, variables, and the other things that has to do with queries. And we're also going to be talking about mutations as well. So I'll see you guys on the next one. Catch you. Bye.